All right, very last day here of 2.5. Now we're going to use your graphing calculator, and we're going to kind of use it as shortcuts when we use synthetic division and we find all the zeros. Again, we're still going to do the same process, find all the factors, find the zeros, but now we're going to use the graphing calculator. Now, you see the first question says, what does the graphing calculator help us do? Really, what the calculator does is it can eliminate the whole rational zero test. So let's put here rational, we'll just abbreviate that, rational zero test. I'm not even going to deal with the whole plus or minus P over Q because now I have the graphing calculator. I'm going to graph the function first and see where it hits the x-axis. And now that I know where it hits it, I'm going to take those numbers, the x values or the x-intercepts, and use synthetic division for it. And I'm still going to do the same thing. Use synthetic division, get it down to a quadratic, to figure out if those last two zeros, if it gives us, if I have to use quadratic formula, and if it gives me complex zeros. All right, let's do the first one. Now, I can't show you on here the actual graphing calculator, so I'm going to draw the picture of the graph on here. You should be doing this at home. So the first thing you should do for number one, put this in for f of x in your graphing calculator. So do that right now. I'm going to show you what the graph looks like. So when you put this graph in, this is what the graph looks like. Okay, I'll put it right over here. Looks like it hits it at two places. All right, looks like this. Okay, and it bounces and it goes straight up. This is what the graph looks like. Now these are zeros right here. Now if you find the zeros, and again, I'm going to go over this in class, how to find the zeros on the TI Inspire. I think a lot of you already know how to do it. This zero is x equals 2. This, or excuse me, x equals negative 2. And this zero is, the last one is x equals 1. Now we have to apply the whole concept of multiplicity. This is a bounce. So what that means is that at x equals 1, we're going to use synthetic division for this at least twice, or it could be 4 times. Now, the degree is 5. Let's go over our options here. Okay, eventually I'm going to erase this. Okay, you don't have to take this down, the options. Now, here are my options for f of x. My factors are, let's see, if negative 2, if this is a 0, the corresponding factor is x plus 2. If x equals 1, if that is a 0, then its corresponding factor is x minus 1. Now if you look how it's written, if you FOIL this out, your degree would be 2. We need to get this to be a degree of 5. Now since there was a bounce here at x equals 1, this has to at least be 2. Okay? Now you look, if you multiplied, your degree would be 3. This could be a degree of 3 because it goes straight through at negative 2. I don't know. I have to use synthetic division for 1 and negative 2 to figure out. The other things that could happen, I could say, let's see here. I could say this is x plus 2 raised to the first power. I'll put 1. The x minus 1, that could be raised to the 4th because it's still going to bounce. The other thing that could happen is that I could have x plus 2 times the quantity of x minus 1. And I could say this is squared. And then I'll put here the other 2. Right now, your degree is 3, 1 plus 2. So that means the other 2 are complex. This is what the graph enables us to do. So there's 3 options. In order to figure out which of these 3 options there are, I have to use synthetic division with x equals negative 2 and x equals 1. So it's real important to understand what this is. You're probably not going to do this for every problem, but I think it's real important to start out understanding, okay, you know, where am I going to get a bounce? Well, these are going to be even multiplicities. So for this x equals 1, I have to do synthetic division for this at least twice. All right, so let's get into the synthetic division. So I'm going to erase really mostly everything here that I did just to save space. Okay. Okay, I'm going to get rid of the graph, and I'm going to use 2 and -1. All right here. Okay, so let's use synthetic division. I'm going to put 1 in here, and let's put in, we got 1, 1. Oh, actually, there's no x to the 4th, so I got to erase that. So it's 0x to the 4th, 1x cubed, 2x squared, -12x, and 8. And I know I should get a remainder of 0. Okay, bring down the 1. 1 times 1 is 1. Add 1, we get 1. 1 times 1 is 1. Add the 1s, we get 2. 2 times 1 is 2. 2 plus 2 is 4. 1 times 4 is 4. -12 plus 4 is -8. -8 times 1 is -8. Add these, we get a remainder to be 0. Now, there was a bounce at 1. So that means it's got to occur at least twice. So it's got to occur at least 2 times or 4 times. So let's do this. Okay, I should get 0 again. So I want to bring down the 1. 1 times 1 is 1. Add the 1s, we get 2. 1 times 2 is 2. 2 plus 2 is 4. 4 times 1 is 4. 4 plus 4 is 8. 8 times 1 is 8. And there it is, our remainder is 0. So now this right here, this is a degree of 3. So I need to do at least one more time. Well, I know the other 0 was -2, so let's do that. Okay, let's move this up. Oops. Okay, and I should get remainder of 0 again. So I bring down the 1. -2 times 1 is -2. I add these. 2 plus -2 is 0. 0 times -2 is 0. 4 plus 0 is 4. 4 times -2 is -8. So there it is. My remainder is 0. All right. Now this is the quadratic. I'm still doing the same thing. I want to use synthetic division until I get the original f of x to a quadratic. Now this quadratic is 1x squared. There's no x value. It's 0 plus 4. Now this is going to tell me I set this equal to 0. I'm going to get 2 complex zeros. So when I solve for it, I have x squared equals -4. Take the square root, and we're going to get x equals plus or minus 2i. Okay, so when I do everything here, I'm going to squeeze this up here. And again, most of the ones for these couple sections, I'm really squeezing a lot in. It's kind of tough to put this using the iPad and fit everything in. So let's see here. The 5 zeros, I'm going to put 1. Now I'm going to list 1. I'm going to list it 2 times because there's a bounce. It's a double root. And then I want to put -2. And I got this by using the graphing calculator. Now in order to get the other 2, I have to use synthetic division, and I got plus or minus 2i. So these are all the zeros here. Okay, so really, you're doing the same exact thing that we've been doing for like the last week. Use synthetic division, get it down to a quadratic, which is this right here. And the quadratic will really tell you if it factors, if you have to use quadratic formula, or if you get complex zeros. But now we have the help of the graphing calculator. So I'm going to eliminate all the whole plus or minus p over q. We're getting rid of that, and we're going right to the x-intercepts and using synthetic division for that. Okay, I'm going to stop there because I know that was a lot. That was a lot for one problem. And the rest, 2, 3, and 4, I'm going to go over in class tomorrow.